Now in the previous video we have learned what is all pair shortest path problem. In this lecture we will take one algorithm and perform it on a real example to see how all pair shortest algorithm work. Now let's say we have a graph like this and we want to perform on this all pair shortest path. So as we mentioned, all pair shortest path means we have to take all vertices as a source vertex in each iteration. So here as an algorithm I will use Lancaster's algorithm. So let's say in the first iteration we take E as a source vertex and we try to find the minimum distance from E to all other vertices. So when we perform Lancaster algorithm for this graph over here by taking E as a source vertex, the solution will be like this. In the first iteration we are setting all vertices to infinity and we are setting the source vertex to 0. Then based on this 0 we are calculating the cost of going from source vertices to all other vertices. So in the first iteration we are calculating that to go from E to D and from E to B is 2 and 4. Then in the next iteration we are calculating that B is changing to 3 because there is a better way going to B from E, which is DE, so it takes 3 units of cost. Then based on this one we are calculating C, and based on B's improved cost we are calculating A. So by taking E as a source vertex our solution will be like this. So from E to go to B we can go DB, and from E to go to A we can go DBA, and from E to go to C we can go EDBC. So our solution will be like this. So we took E as a source vertex and the minimum path from E to any other vertices is like this. Now in the next iteration we are taking D as a source vertex. So if we calculate same way that we did for E, the solution will become like this. So first we are setting D as 0 and any other vertices to infinity, and then based on this 0 we are calculating other vertices cost. So at the end the solution becomes like this. So our solution from D to all other vertices will be like this. So from D we can go to C straight away, and from D we can go to B straight away, and we can go from D to A by using D vertex over here. So the path is BDA. So this is our solution when we take source as a D vertex. Now here you can see that from D we cannot go to E because here we don't have any way to go to E. So here that's why I've mentioned it not available. Now if we continue to the next iteration, in the next iteration for example we are taking C as a source vertex, then based on this we are calculating the cost. So I'm not going to the details because I have explained it in case of single source shortest path problem. So here I'm showing the solution for C vertex when it is source vertex. Then in the next iteration we need to take source vertex B. So based on that we are calculating the path. So the optimum path will be like this. And in the next iteration we are taking A as a source vertex and calculating the shortest path to all other vertices based on A. Now here you see that we have run iteration V number of times, where V stands for the number of vertices in the graph. So in this graph you see that we have 5 vertices. So here you see that we have 5 solutions, so which means that we have run single source shortest path problem 5 times for all pair shortest path problem. Now in our case we have used Lancaster's algorithm, but we can use in similar way BFS and Bellman-Ford algorithm. So here also if we take BFS algorithm we are taking all vertices as a source one by one and calculating the shortest path from that vertex to other vertices. So hopefully you have understood how we can use these 3 algorithms for all pair shortest problem. Now in the next video we will learn new algorithm which can also be used for all pair shortest problem, which is called Floyd-Warshall algorithm. So see you in the next lecture.